All right, we're back again and we are doing graphs, functions, and our focus today is just the parabola. So now on the board you see parabola, and then you see y is equal to ax squared plus q, right? Ax squared plus q. All of that is important. It is important, and I'm going to explain to you how you see certain graphs, how whatever you see in the equation, what's important about everything that you see, like individually. Okay, and so you'll see that here we've got a Cartesian plane, something that you should have, that you should know from grade 9. Yeah, and then you have your y-axis and your x-axis. The y-axis is vertical, the x-axis is horizontal. And then so let us look at all of that information to understand what each of these things mean here on our graph. Okay, so we've got A is positive. Do you see that there it says A is greater than 0? That means that A is positive. Okay, A is positive. So if it is positive, think about this. So this is what I usually say to my learners. If something or someone has a positive attitude, they smile, right? And so a positive attitude is smile. So let me do this here. That is greater than... I'm just going to put a plus there so that you know that that's positive. So we need to know that greater than 0 is positive. If you remember your number line, here's 0, but the moment you start moving to the right, but you're looking at me, so your right would be there. If you start moving to the right, the numbers increase, right? So from 0, you get 0.1, which is a positive if you start going to the right. So basically, that's why anything greater than 0 is positive. And then when you have a negative attitude, you're sad. You have a frown. So that there is going to be negative. So I've got a negative under the frown. Okay, so anything that's less than 0, if you start moving to the left of 0 on your number line, so here's your number line, your left is your right is that side, your left is that side. So when you start going that way, then your number line is negative. Okay, but anyway, don't worry about my directions, because I can't see, I can't actually imagine what you're seeing. But anyway, so maybe let me just do this quickly. If you going to the left, that way, it's negative. If you going that way, it's positive. That's what I'm trying to say. So here's 0. If you go that way, you're already going to the positive, and you're already leaving the neutral point, which is 0, and you're starting to add. That's the positive. But when you start going that way, which is negative, then it's that's to the left, right? Yeah. So then that means your graph is going to frown if it is less than 0. If it is positive, greater than 0, you're gonna smile. Positive attitude, negative attitude. Remember it that way. Cool. I hope that makes sense. I just wish I didn't have to do that. But anyway, let's continue. We've now talked about the A. The x, I said, will always be part of your equation, and your equation is known by an x squared, right? If you have an x squared, then you know you're definitely dealing with a parabola. Okay, and so let us go on to Q. By the way, this coordinate here is 0 and Q. That coordinate there is 0 and Q. Okay, so now what you need to know about the Q is that Q is the Y-intercept. You remember from the straight line graphs that I taught you, or whoever taught you, if they taught you correctly, that your y-intercept is where your graph cuts your y-intercept, where your graph cuts your y-axis. Your y-intercept is where your graph cuts your y-axis. Okay, do you see this here? There at the bottom, that's where your graph cuts your y-axis. Okay, and so if your graph cuts your y-axis there, it is that value there. Okay, and we know that if we are finding the y-intercept, we let x equal 0. What is x there? It is 0. Do you see that? Okay, so x is 0, q is q. So basically, again, this is your turning point. That is your turning point. Okay, so you should be thinking, man, now, I can get my turning point by doing the y-intercept. When I do my y-intercept, I let x equal 0. So if x equals 0, that means that is my turning point for a parabola. Cool. So that's easy stuff. Do you see that? And also your y-intercept or your q is known to be either your minimum or your maximum point on the graph, or on the maximum value, right? So listen to this. Minimum, why is it the minimum? Do you see this point here? Would the graph ever pass beneath that? It would never. It can't go anywhere below that part. So you need to know that that is the minimum point of your graph, because from here it's going up and up and up and up to infinity. Do you see that? So it will never go anywhere beyond this point here downward. Never. Okay, let us go on to what else do we need to do? We are now doing, so now the maximum. So if you were dealing with a negative graph, a negative parabola, meaning that your graph would be frowning, your maximum point would have been, obviously, let's say it turned somewhere there. That would have been your maximum point, because from there it goes down. You see that? And if it goes down and down and down and down to infinity. So yeah, negative infinity. Cool. So yeah, why did I even say that? But anyway, yeah. So that is basically what it means. Okay, maximum would be coming from the top. Minimum would be coming from the bottom, going up. Okay, and that's from the turning point. Now let us look at axis of symmetry. Axis of symmetry. You see the way it says x equals 0? Where does x equal 0? At the turning point. Now, it's not always, x is not always going to be 0 at the axis of symmetry. It's not always going to be 0 at the turning point. It can be, your axis of symmetry can have an x value of something that is not 0, because your turning point isn't always at this point here. It is not always on x equals 0. Okay, so what am I saying? I am saying to you that your axis of symmetry is what cuts your graph in exactly half. So if you're to take this part here, and fold it, you should have the exact same graph on this side. So if you take this here and you fold it, so you're folding it from the y-axis and you fold it that way, this line joins this line, and this line now turns and changes direction. It joins this line. So basically that is what an axis of symmetry does. It cuts it exactly in half, and in this case it is on x equals 0. Where is x equals 0? There. You see that there? Because when you move that way, your x increases. When you move that way, your x decreases. So on your y-axis, basically this is the line y, not y, x equals 0. Your y-axis is the line x equals 0, and your x-axis is the line y equals 0. I'm just putting it there for your interest's sake. I hope you can see it. Okay, but anyway, let's continue. Domain. Domain deals with x. domain deals with x. Okay, so x is an element of real numbers. Now let me tell you what this means. Look at your graph. Do you agree with me that if we drew this graph, and if I went onto my wall and to other things there that you can't see, if I did that, do you agree with me that the x value would continue going that way and nothing would stop it? That's why these arrows here are very important. Arrows. You see those arrows? They're very important. You better make sure that you write your arrows down, because that's what it means. It means that the graph continues to go. It does not stop. Do you see that? Cool. So now that's what it means for your domain, your x, to be an element of real numbers. What are real numbers? It's actually all the numbers that you can get on your x-axis. Because x, also, do you see that the x-axis does not stop there? There's an arrow. It means it goes on to infinity. Cool. So that's what that means. Now listen. What about the range? What about the range? Y is greater than and equal to, or equal to and greater than Q. Where is Y equal to Q? Here. Do you see that? Excuse me. Do you see that there? Y is equal to Q there, right? And then what does that mean? It means Y, the range, is from this point and greater than this point. Do you see that? It's from this point and greater than this point because it goes up. Now, if it goes up, so remember, I just told you now about the x's. You see that the arrows are going that way? Remember, it goes that way, but it's still going up. Do you see that? And so that's why with y, it's also just from that point where it starts and then it goes up. It's real for all of those points from where the turning point is upward, because even the arrows upward are to infinity. If you draw your graph, something like this here, just know that it is wrong, because what this means, it means that it will never touch all the y values. It means that it will start turning, and maybe you will have a different type of graph where it looks something like this. Let me show you what I'm talking about. If you have a turning point there and you draw your graph that way, that's not right. Because what you are saying is this: if this was to go to infinity, it will eventually come down again. So do you see that you can't say y is an element of real numbers? Do you see that? You can't. But if you have it this way, it is facing upwards. It's going up and it is spreading wider. So if you go to infinity, nothing will stop you. So y is an element of real numbers where y is equal to and greater than q. This thing here under the greater than sign means equal to and greater than q. And it is only applicable because of a is greater than 0. Let me explain what that means. That means that a is positive. A is positive. A is positive. It's a smiling graph. Do you see that? So this here is applicable only if your graph is smiling. Do you see that? If your graph is smiling, then it makes sense for y to have an element of real numbers going upwards. Do you see that? So it could go downwards, but it doesn't. It shouldn't. It shouldn't, because your a is positive. Do you see that? If a was negative, it would be a different story. That would mean that your graph is frowning, and so your inequality sign would have to change, or your inequality sign, let's call it an equal, or less, your greater than sign would have to change. So let us have a look at the second one, or the opposite one to that. We have y is equal to and less than q, right? The range is y is equal to and less than q. Y is an element of real numbers if a is less than less than 0. So this one here is not for this drawing here. I'm going to show you what the drawing for that one is. The drawing for this one here, if they ask you for the range, is this here. Let's call that there. It'll turn there. You see that there? Do you see that? So if a is less than 0, you're going to have a frowning graph, and you're going to have y is an element of real numbers going down. So you are saying if y is less than and equal to q equal to and less than, do you see that? And that is because a is negative. You can only use that if you have a frowning graph, and you can only use the first one, y is equal to and greater than, if you have a smiling graph. Please do not waste these marks. They ask you what is a range, they ask you what is a domain. Those are free marks. You just need to know what that means. If you don't know what that means, you're giving away 1-2 marks depending on which grade you are, but mostly it's 1. Okay, so just make sure that you understand that, and if you understand that, then you're good to go. Cheers. Catch me in the next one where I do actual songs. Cheers.